In the late 1980s, the Soviet Union claimed a feat many military experts thought impossible. K-147, a Victor-class nuclear-powered attack submarine, secretly followed the trail of a U.S. boomer, most likely the USS Simón Bolívar, in an underwater game of chase that continued for 6 days. U.S. observers at the time thought the Soviets lacked the tech for effective sonar, at least in comparison to the capabilities of the U.S. and its NATO allies. Now, a newly declassified CIA report shows how hunter submarines like the K-147 went on secret missions to track American subs without using sonar at all. The CIA's Directorate of Science and Technology produced the report on Soviet anti-submarine warfare capability in 1972, but it was declassified only this summer. Even 45 years on, lines, paragraphs, and even whole pages are redacted. A lengthy portion about Soviet technology under development gives details never previously revealed about devices with no Western equivalents. While NATO were concentrating almost all their efforts on sonar, the Russians created something else entirely. Seawater blocks radio waves. So radar, while effective on the surface, is useless underwater. Sound waves, on the other hand, travel better through water than they do through air, and as early as World War I, they were put to work finding submarines. Sonar comes in 2 basic types. There's active sonar, which sends out pings that are reflected by the target, making it an underwater version of radar. Passive sonar, on the other hand, is based on sensitive listening devices that can pick up sound from a sub's engines or propeller, and unlike active sonar, it does not give away your position. Depending on conditions, sonar can find a submarine from many miles away and in any direction. The U.S. and its allies developed sophisticated sonar systems, which soon became so effective that other methods of detection were left behind or forgotten. For decades, non-acoustic methods were considered inferior for being limited in range and reliability compared to sonar. It is unlikely any of these methods will enable detection of submarines at long ranges, concludes a 1974 intelligence report. In the USSR, it was a different story. The Soviets were hampered by primitive electronics and struggled to make sonar work at all. So instead, they developed other weirdly clever means of submarine detection. On such method highlighted in the report is the Soviets' mysterious SOKS, which stands for System Obnarżenia Kilwaternowo Sleda, or Wake Object Detection System. This device, fitted to Russian attack submarines, tracks the wake a submarine leaves behind. SOKS is actually visible in photos of Russian subs as a series of spikes and cups mounted on external fins. The Soviet claim of following subs without sonar sounded like typical Russian bluster, but without knowing how or whether SOKS worked, a realistic assessment was impossible. The Pentagon has classified this entire area of research and scientists simply didn't talk about it. Rumors out of Russia about SOKS have been inconsistent and often contradictory, with some saying SOKS measured changes in water density, or detected radiation, or even used a laser sensor. What the West knew for sure was that SOKS gear first appeared on K-14, a November-class sub, in 1969. Since then, subsequent versions with codenames like Colossus, Toucan, and Bullfinch have appeared on every new generation of Soviet and Russian attack submarines, including the current Akula and forthcoming Yasin class. According to these newly declassified documents, the old rumors were accurate in one way: the Soviets did not develop just one device, but several. One instrument picked up activation radionuclides, a faint trail left by the radiation from the sub's onboard nuclear power plant. Another tool was a gamma-ray spectrometer that detects trace amounts of radioactive elements in seawater. The Soviets had reportedly had success detecting their own nuclear submarines, several words redacted, with such a system, the document says. The report also describes how submarines leave behind a cocktail of chemicals in their wake. Sacrificial anodes that prevent corrosion leave a trail of zinc in the water. Minute particles of nickel flake off the pipes circulating seawater to cool the reactor. The system that makes oxygen for the crew leaves behind hydrogen that's still detectable when dissolved in seawater. Together, these chemical traces may measure only a few tenths of a part per billion, but sophisticated equipment can find them. And as you'd expect, a nuclear reactor also leaves behind tons of heat. According to the report, a large nuclear submarine requires several thousand gallons of coolant a minute. This water, used to take heat from the reactor, may be 10 degrees Celsius warmer than the surrounding seawater, creating a change in the water's refractive index, a change that's detectable with an optical interference system. And the Soviets did exactly that. A localization system based on this technique, capable of detecting wakes up to several hours after the passage of a submarine, could theoretically be built now, says the report, though it was not known for sure if the Russians had done so. The sensors would not simply say, "Here is a sub," but would generate a stream of numerical data. Picking out the signature of a submarine from the background noise in the data takes some computing power, and the report notes that, in the 70s, the Soviets were far behind in this area. These days, the Russians can acquire commercial machines thousands of times more powerful than any they had then, and that may have given SOKS a major boost. The report shows that even in 1972, intelligence agencies were aware of how US subs might be tracked. Countermeasures surely would have been put in place since then, such as reducing the chemical and radioactive trails, which is probably why it took 45 years for this document to be brought to light. Still, new versions of these technologies are far more capable than their water-snooping forebears. Recent scientific papers suggest the Chinese are now investigating new submarine tech, and even the US Navy and DARPA have started to take an interest in wake tracking, suggesting that the tech isn't quite as inferior as previously thought. Whether Russians can still stealthily follow submarines, or if the US found a way to foil them, is impossible to know. We'll probably have to wait another 45 years for the heavily redacted answer.